In this problem, we're differentiating a function of a function of a function. So we're going to have to use the chain rule twice. And as a first step, I'd rather re-express that square root as a fractional power. Now our outermost function is that power function. And when I differentiate with respect to the interior of that, I just use the power rule and I have 1/2 times that interior to the -1/2, subtracting 1 from the exponent there. But then the chain rule kicks in and says you have to tack on the derivative of this interior piece. That's going to take more than one step because that interior piece itself is a function composition. So what I like to do is just slow things down and just make a note to myself with a little prime here that I still have to differentiate that interior piece. In the next step, I'm going to simplify this first chunk and deal with the derivative in the second chunk. So a power of -1/2 means that we're going to have a square root in the denominator of this thing. And there's a factor of 2 down there. And then I'm going to deal with the derivative of this second piece. So the derivative of 2, of course, is 0. It's the secant pi x squared part that's interesting. And we start with the derivative with respect to pi x squared. And that gives me the secant of that, pi x squared, tangent pi x squared. And then the chain rule says I need to multiply by the derivative of that interior piece, pi x squared, and that's a 2 pi x. Some 2's are going to cancel. And I'm going to rewrite the whole thing as a single fraction. And we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.